want to do a video walkthrough of this problem here. Um, so I've already kind of presented the problem to you. I've worked on some sub problems that I've got to answer, and now I'm working on my plan here. So step one, how much dirt? Seems like a good place to start. Here is a useful resource. This gives me 15.5 million basket loads. And the phrasing of this actually kind of leads into, I'm going to put my resource here, paste. This has saved me quite a bit of time. I could have tried to do some kind of geometrical calculation for a cone or something to figure out how much dirt there was. So that's interesting because this has helped me a lot, and it's given me a little clue here about no use of animals for help moving dirt. We get basket, one basket per person, and assume it has to be transported. Let's see, I don't really know what makes sense here, but let me kind of try to do another little bit of research. See, probably wait. I don't want to do this on Google Maps, so let's do Maps on Google. Poverty point. So here we are. So we're bringing dirt over, I don't know, maybe like, I mean, the problem is you're trying to move dirt from one place to another, and if you like are doing it too close, then you're kind of lowering the ground next to you. So let's just assume, how do I put a pin down? In down Google Maps. Desktop, right click, okay. Measure distance. Okay, 2 miles. 2.15 miles. So let's just say if we went 2 miles away, we would, we're going far enough here. So 2 miles to digging to putting dirt in the mound. Okay, so then every trip then is 4 miles and consists of digging, although I suppose we could sort of split the labor of like the digging people could just be putting baskets, and then the walking people could just be carrying the basket. All right, so labor hours. So one basket is one trip. One trip is 4 miles of walking. Plus you have digging and putting in place happening. Let's say 3 people doing work simultaneously. Yeah. Focus on the transportation part of this. So I got a new sub question. How long would it take a person to walk 4 miles? Okay, so now I need to answer this question. And there's various ways I could do that. I'm just going to do research again. So let's go back here. Average human foot speed miles per hour. 3 miles per hour. Okay. So then I guess if an average human walks 3 miles per hour, but part of this journey is with a basket full of dirt. Let's say, let's see, no dirt would be 6, so 6 miles for 2 hours. Yeah, let's just say 2 hours of walking. Since half the journey is with this basket full of dirt. Okay, so one trip is 2 hours of walking. So then we have 15.5 million baskets means 15.5 million trips means 31 million hours of walking. Plus whatever we need for digging and shaping a mound on either end. I'm going to ignore that part, but try to keep in mind that not every person available to work would be walkers. Okay, so now 31 million hours of walking is the main number of labor hours I need to get back and forth. So let's see. Now I need to figure out how to convert labor hours to years of labor. I need to know new sub questions. How many laborers were available and how many months were they laboring during the year? Okay. So first question, I'm gonna try to get how many laborers were, no, how many people living in poverty point. All right. Thousand people. All right. Let's say 9,000 people. I'm not quite sure where this is coming from. Good to get a real site here. Hmm. Mhm. How many people live in poverty? I guess I just Googled that. Britannica, 4,000 to 5,000. Okay. All right. So let's see, 4,000 to 5,000 people. 4,000 to 5,000 people. And assume that a percentage of people are, let's assume that any adults, any kind of able-bodied adult would be not 18 or older, but 65, 15 to 64. All right. I mean, 64-year-old hauling dirt around seems a little hard, but let's say 65%. We just gotta keep moving forward here. Assume that 65% of these would be adults able to contribute. That is whatever 65% of 4,000 is, calculator out here. Okay, and then it's 2,600 laborers, but only 2,000 would be doing the hauling. I don't know, just kind of spitballing here. So 2,000 people. These laborers would be able to work 8 hours, maybe for probably decent weather for about 5 or 6 months, 180 days, but you're not working every single day. So let's say 150 days in the year. So that is 8 times 150, that's 1,200. 1,200 labor hours per person per year. Okay, so now we have 2,000. Now we have 2,000 laborers working 1,200 labor hours per person per year. So we are producing 2,000 times 1,200, 2.4 million labor hours per year. And we needed 31 million hours. Since we needed 31 million hours, we would be needing 31 divided by 2.4, 13 years of significant dedication and labor to get this mound constructed. Okay, so that's working through the problem, encountering new sub-problems as I went, using combination of internet research. I should probably show this couple of places that I brought in here. 65.2%. There we go. So there's this part. That's where I got the 65% from. Insert link. Okay, and then 3 miles per hour. That was another part that I should have linked. Average, here we go, that one. This is medical news today. Okay. Yeah, oops. Here. Let's see. For this one, I didn't. Where did I get that from? How many people in Poverty Point? Is it this one? Yeah. So I'm just rereading it. This was developed from Google Maps. From the consideration that not every working adult is doing the walking. So 31 million divided by 2.4 million. Okay. All right, I'm gonna stop there. I think this is, hope that was helpful. That's me working through my own problem.